Okay, these next two terms are kind of fun, and they're the last two I'm going to do before our next video. In the next video, I'm actually going to show you how these two terms can actually interact with each other, which is kind of neat. The kids always get a kick out of it because it's one of those ones where even if you don't comprehend what's really happening, it's something you can do just because there's a really simple set of steps you can follow. So it's a really neat little mathematical game if you want. I mean, the kids can have real fun with it. The two terms we're going to look at are mixed numbers and improper fractions. And these two terms come into play when you get to fractions of more than one whole object. Up till now, we've talked simple fractions. What a simple fraction simply said was, I've got one object, and as we had mentioned earlier with that one whole object, I was breaking it into so many pieces. So with 2/3, for example, I take an object, it could be a pie, I mean it could really be anything, or I could take a set group of objects like the example we did with the gardening tools and say, okay, here's one certain part of that group, here's another part of that group, here's a third part of that group. One of them is this type of garden tool. So we had the rake, the shovel, and the hoe, and I said, okay, one out of these three groups is rakes. So 1/3 of the objects are rakes. Well, with a simple fraction, what you're really doing is you're taking one object and you're cutting it into pieces. In this case, I cut this object into 2/3, with 1/3 of it being left behind, that it's not being used. What mixed numbers and improper fractions say is, wouldn't it be nice in life if you had to cut up one piece of pipe into fractions as opposed to 10 or 12 pieces of pipe? And we all know that usually when you have to cut up one object, you're going to have to cut up another. When you order pizza, for example, pizzas normally come with 8 pieces. Well, that's wonderful, but if I order 2 pizzas, I'm getting 2 pizzas that were both cut up into 8 pieces. And then you have to figure out, well, okay, how many pieces have been eaten or how much do we need? And you can do that using mixed numbers and improper fractions, because they're going to tell you, okay, of the more than one whole group I had, how much was actually eaten or needed? So, for example, here we have mixed numbers first. And a mixed number, you're going to notice very quickly, has a whole number in it, as opposed to just the fraction. So in this case, if I took an object, or actually if I had 3 objects here, and said, okay, I used all of the first one. So you'll see I used all of this object. We could say it was a Trivial Pursuit piece. We could say it was a food item. We could say it was, you could pretty much make it anything you wanted. But regardless, this one was cut into 3 parts, and I used all 3 parts, so I used the whole object. This one, the same thing, cut into 3 parts, I used the whole object. This one, cut into 3 parts, but I only used one of them. So I have the whole number 1, whole number 1, and then the simple fraction, and actually the unit fraction, 1/3. To represent that as a mixed number, and it's mixed because I have the whole number and a fraction, and I think that one's kind of obvious that it's mixed because it has 2 things that aren't exactly the same put together here. We have a whole number and then the unit fraction in this case, or a simple fraction. So in this case, I had 2 whole objects and a third more, so 2 and you're going to notice we say and between the whole numbers and the fractions, and this is something I push with the kids. When we're reading any numbers, including when we switch over from fractions to decimals, that word and is important because and represents a movement from whole numbers to fractions or decimals. So 2 and 1/3. So I have 2 whole objects plus 1/3 of another. Now you are going to notice, and this was something the kids sometimes struggle with, the objects have to be, or even the groups have to be divided into equal parts. I can't have one of these be a 4th, and then one of these be a 3rd, and one of these be a 7th, and then say, oh look, it's 2 1/3, because in truth it's not. While I might have 2 because these 2 are fully used, now I've got 2 full objects, and it really should have been then a 7th if I said this was a 7th. And it's very important, though, that these share the same parts, that they're broken up in the same way, and that's going to show up more in the improper fractions, but even in the mixed numbers, it's really important that they be equally broken up. Now, an improper fraction, and you're going to notice in the drawing, I did the exact same drawing as I did for the mixed number, because an improper fraction shows the exact same thing a mixed number does, just in a different format. You'll notice in this one, I'm saying, instead of saying I used one whole object, I used 3/3 of the object. And that still means 1. What it really says is, we cut the object into 3 parts, and we used all 3 pieces. Same thing here. Cut the object into 3 parts, used all 3 pieces. So again, it still means 1, but because it's working with an improper fraction, which if you look here, it has no whole number with it, it's easier to look at them and think of them as a fraction as opposed to a whole number. And then, of course, my third object, again, split into 3 pieces, divided into 3 pieces, cut up into 3 pieces, however you want to put it, it has been divided into 3 pieces, and I am only using one of them, so I'm using 1/3. So that is the fractional part of the improper fraction. Now, the way we write the improper fraction is, and this is how it's different than the mixed numbers, I'm going to take those numerators and I'm going to say, okay, in this object, I used all 3 pieces. That's a 3. In this object, I used all 3 pieces. That's a 3. 3 plus 3 is 6. In this object, I used 1 piece. I'm going to add, sorry there, it's going off the screen. I'm going to add 1 more piece. 3 plus 3 plus 1 is 7. So in my numerator for an improper fraction, I'm going to give you the total number of pieces amongst all of these objects that I've used. But wait a second, why is this still a third then? Really, there's 9 pieces there. Right, there are 9 pieces amongst these 3 wholes, but remember what the definition of denominator was. It said it was the value of how many pieces had been, or how many pieces a whole number, one whole number, had when it was split up. And that's why we cannot divide these all differently. They all have to be divided the same. This one has to be thirds, this one has to be thirds, this one has to be thirds, so that the denominator remains thirds. It's saying every single whole piece was divided into 3 pieces. I used 7 pieces. Well, if you think about it, what that's really saying is 2 1/3. If I'm saying I used 7 pieces, I used 3 here, 3 here is 6, 1 more here is 7, 7/3. And that's where improper fractions get a little confusing. And that's why I always tell the kids, we love to use improper fractions when we have to add, subtract, multiply, or divide fractions. But when you get done, you still always want to change your answer back to a mixed number, because in our minds it's much easier to picture a mixed number. We can picture 2 whole pieces and a third of another one. We can picture eating, well, I can picture eating 2 whole pizzas and a piece from the other one. But when we see it as 7/3, we don't think that way. It's very hard for us to comprehend that and say, okay, that means 3 pieces per object. 7 means, okay, if there's 3 per object, I have to use 3 from the first one, 3 from the second one. Okay, I've used all of those 2, and then I've got 1 left over. It's a lot for us to comprehend. We need the improper fractions when we go to add and subtract, and you'll see that in the future videos. But always our answers are going to come back to become a mixed number.